Hello everybody. The plan for this recording is to talk through solving polynomial and rational inequalities. In previous videos we've talked about how to solve polynomial equalities or functions and how to solve rational functions. So now we're just going to take that to the next step and solve polynomial and rational inequalities. So that's kind of the plan for this recording. So let's get rolling. We're going to solve a quadratic inequality by first finding out where it's equal to 0. And then we'll worry about where it's less than or greater than 0. Okay? So let's think through all of our techniques of how to solve a quadratic equation that is set equal to 0. We could factor it. We could quad form it. We could complete the square. Those are probably the main ones. So out of those techniques, the first thing I would try factoring. If it doesn't factor, then go to the quadratic formula. The goal, find out where this thing is equal to 0. Find out the values for x that make my equation equal to 0, and then we'll worry about the inequality sign. So let's try factoring. First thing, what gives me x squared? X and x. Next step, I'm going to get rid of this one here. It's a little too close. Next step, let's factor the 4. Factors of 4 are 2 and 2, 1 and 4. I want factors that will subtract to give me 3. Well, 1 and 4. I want a positive 3. So I need a positive 4 and a negative 1. Okay? And I want those to be greater than 0. So let's finish. What makes them equal to 0? Well, when each factor is 0, right? So when x equals 1 or when x equals a negative 4. Now, there's only a couple ways, or actually there's only one way, of making something equal to 0. And that is if one of the factors is equal to 0. Well, how do you get a positive? Right? Isn't that what that says? I want to know when will these products be greater than 0. When will the product, right, that's what's happening right here, we're multiplying. When will the product of two numbers be positive? We have a couple options, right? We could have a positive times a positive. That's positive. Or we could have a negative times a negative. That's also positive. There's a lot of combination of numbers that will make both factors positive and both factors negative. So you can see, like any inequality, my answer is not going to be a number, but it's going to be a range of numbers or an interval of numbers. Okay? So to help us organize our information, we're going to make a number line. I'm going to make a number line. On that number line, I'll put the values that make the equation 0. Now, I want to know where they're positive. So if it's equal to 0 at these two numbers, then hopefully we all agree that the only way to get from a positive to a negative is if I pass through one of these two numbers. The only way to get from a negative 5 to 0 or to positive 5 is if I go through 0. So if I just check a single point in every region, I know that every other point in that region will give me the same sign, positive or negative. And I will explain that more as I go. So that's my thought process. I'm going to go through each region, meaning I want to find out, is that region out there positive or negative? Positive or negative, in between negative 4 and 1. And then out here, to the left of negative 4, will it be positive or negative? I want to know the sign of each of those regions. Okay? Let's plug in something greater than 1, like 2. 2 minus 1, if I plug in 2 for x. 2 minus 1 is positive, right? 2 plus 4 is positive. So I have a positive times a positive. Every number out here, when plugged into that equation, when I plug it in for x, the product of those two numbers will always be positive. Why? Because the only way those factors will change signs is if I switch sides from the one side of the 1 to the other side of 1. Because at 1 is where one of those factors is 0. So it cannot change signs anywhere out here because there's no place out there where one of those factors is equal to 0. It will have to remain positive. So my point is I don't need to check any other point. Checking a single point is all I need to do. Okay? So let's check a single point in between -4 and 1. How about 0? 0 is in between those. 0 minus 1 is a -1. And 0 plus 4 is a positive 4. So now I have a -1 times a positive 4, and a negative times a positive is negative. When I plug in every number between -4 and 1, the answer, or the product, will be negative. Okay, let's pick a number that is to the left of -4, meaning less than -4. How about a -6? -5, doesn't matter. -6 minus 1 is a negative. -6 plus 2 is a negative. And I have a negative times a negative, which is a positive. Now, what's my answer? I want all numbers that are positive. Let me rephrase that. All numbers that will make my product positive. Well, as long as x is greater than 1, or if x is less than a -4, my product will be positive. How do I know? Because that says it will be. And notice, if this is less than or equal, if this is not equal to, then my inequality down here will not be equal to. Okay? How do I graph that? I have an open circle. Let me get rid of this. I have an open circle and an arrow going that way. Or another notation is interval notation, and I have a parentheses and an arrow going that way. Now, I could write this in interval notation also, which you will definitely see, and it's on the homework. That is interval notation, union with that. You can never include the infinities, but sometimes we will include the -4 or the 1. Either notation is fine. You should know both. Okay, for this class, you should know both. For any class, you should know both. All right, just like all my recordings, once you think you've got the hang of it, give it a try. Meaning, hit pause and try the problem and come back and listen to the explanation. Okay, first step I'm going to do, assume it's an equal sign. If I solve something that is equal to 0, one technique is factoring, so let's factor that thing. So 2x squared factors into 2x and x. Factors of 3 that will subtract to give me 1, but whatever I put here gets multiplied by 2, and whatever I put here gets multiplied by 1. Okay, I'm assuming you've had a chance to think through this, so I'll just put the answer up there. This is a 3, and this is a 1, because 3 minus 2 is 1. I want a positive 1. So the positive needs to go with the 3, the negative needs to go with the 1. Now, what will make 2x plus 3 equal to 0? If 2x equals a -3, or if x equals a -3 over 2. Which, remember, or quickly calculate, is a -1.5. Okay? Grab that, slide it up here. So there's one answer. And the other answer is, well, that works, x equals +1. Right. When you do this, it's pretty important. You put it in order from smallest to largest, or in the correct order on a number line. Negative 1.5 would be to the left, and a positive 1 would be to the right. Okay? Now, here's our here's our technique. Plug in something greater than 1, like 2. 2 times 2 is 4, plus 3 is positive. 2 minus 1 is positive. We have a positive times a positive, it's positive. Plug in something between negative 1.5 and 1. How about 0 again? 0 plus 3 is positive. 0 minus 1 is negative. And a positive times a negative is a negative. Plug in something less than 1.5, like a negative 2. Negative 2 minus, or times a negative 2 times 2 is a negative 4, plus 3 is a negative 1. Negative 2 minus 3 is a negative 3, which is negative. And again, I get a negative times a negative, which is a positive. All right, what's my answer? I want the numbers that are less than or equal to 0. Numbers that are less than or equal to 0 are negative, or 0. And so I'm looking for this region right here now. Why did I put brackets instead of parentheses? Because now I'm including the endpoint. So in my interval notation, it would be negative 1.5 to 1. Every number in between those two endpoints and including the endpoints, which is what the bracket says. Or in inequality notation, it would look like this. It's an and statement. It has to be less than 1 and greater than a negative 1.5 at the same time. Okay? And if we did closed circle, open circle, it would be a closed circle on both endpoints and the arrows in between. Lots of ways of writing it. You should be comfortable with all of them. All right, your turn. First step, set it equal to 0 so I can solve it by our techniques. Next step, I'm going to factor again. If you didn't like factoring, you dumped it into quad form, that's fine. Take those numbers and put them on a number line. All right, factors of 8, 1 and 8, 2 and 4. Whatever I put here gets multiplied by 3. Whatever I put here gets multiplied by 1. And I want the difference between the products to be 2. So I'm going to put a 2 here, and I'm going to put a 4 here. That gives me 6, 3 times 2, and 4. That gives me 2. I want a positive 2. In this case, notice my smaller number will be positive because that is the larger product. And then actually the bigger factor will be negative because that's the smaller product. And there's my factors. What makes each factor 0? Sorry, get rid of all my mess. What will make 3x plus or minus 4 equal to 0? Hopefully you know the shortcut. When x is equal to 4/3. Opposite sign of this number divided by that number. Hopefully over the, I don't know however long we've been doing factoring, that's kind of sunk in here. And then this one is x equals a negative 2. All right. So next step. Put those on a number line. We'll jump out here. We'll switch colors just because that's the color I grabbed off the pen tray. All right, so we have negative 2 on the left. We have 4/3 on the right. 4/3 is 1 and 1/3, right? Okay, so pick something bigger than 1 and 1/3. Let's go obvious. How about 3? If I put in 3, 3 times 3 is 9 minus 4, positive. 3 plus 2 is 5, which is positive. Something between negative 2 and negative 1 and 1/3, positive 1 and 1/3, like 0. Makes that a negative, makes that a positive. My answer is negative, and if you haven't figured the pattern out yet, it goes back to positive. All right, what do I want? I want, again, numbers that are less than or equal to 0. So I want everything that is in between -2 and 4/3. All right, getting a little harder. Give it a try. How do we solve that thing? Let me get rid of my plus sign and my mess. Steps are the same, so you should be able to hit pause and just go. Make it an equal sign. Get the zeros on the number line. Check each region, and then answer the question. All right. What makes this factor 0? -3. What makes that 0? +2. And that would be a -1. Put that on a number line. -3 is the furthest left, then a -1, and a +2. I always start on the right. It really doesn't matter, but I always start on the right. So let's pick something bigger than 2, like 4. 4 plus 3 is positive. 4 minus 2 is positive. 4 plus 1 is positive. Everything out here will be positive. Something between a -1 and 2, like 0. This one's still positive. This one now is negative, and this one's positive. Notice only one changed signs. Which one? The one that had the 0 of 2. Hopefully these things are you're starting to see these patterns. What should happen now? You should know what goes right here. The pattern's been happening every time here. So if I plug in something between a -3 and -1, like a -2, this number here is still positive. This number, -2, is still negative. This number here is now negative. Negative times a negative is a positive. Times a negative is now positive. Notice the sign that changed was the one that was at the factor that makes it a -1. When I went from one side of -1 to the other side of -1, it switched signs. Okay. Left of -3, like a -5, makes this one negative, makes this one negative, makes this one negative. Now this one changed signs. It was positive, now it's negative. All right, what do we want? We want numbers that are greater than 0, which is positive, right? I want all the regions that are positive. So I want when x is greater than 2. I want when x is between. So when x is less than a -1 but greater than a -3. Interval notation, -3 to 1, unioned with, unioned with 2 to infinity. And this would have to be an or in between. Graphing, we have a parentheses here, arrow going to the right, a parentheses here, and a parentheses here. Or we have an open circle here, arrow going in between, open circle here, arrow going forever. All four notations are very common, and you should recognize all of them. All right, one more. We've got to get to rational functions because this video is getting kind of long. But you need to see one more before you think that it's always a certain way, because this one's a little different. Not a lot, but a little bit. Give it a try. Can you read my writing? Probably not. Sorry. That was supposed to be a 3. If you thought it was a 2, sorry, I was in a hurry. Okay. What makes this 0? 4, -1, -3. Let's make a number line. On the left-hand side would be a -3, -1, 4. Numbers that are bigger than 4, like 5. This is positive, 5. This is positive, 5. Makes this positive. However, this negative sign just messed everything up. Well, it didn't mess it up. It made it negative. Right? Positive times a positive times a positive times a negative would be negative. All right. Between a -1 and 4, like 0. 0 makes this negative, makes that positive still, makes that positive still. So now a negative times a negative is positive, and times positives makes that a positive. So that pattern stayed the same. When it went from one side of the 0 to the other, it switched signs. But this one has always been positive up till now. and now it's negative. Why? Because of the negative sign out in front. All right, hope we realize that's what it's going to be, but I'll just double check. Plug in a negative 2, and I get a negative here, I get a negative here, I get a positive here, I get my negative out in front. 3 negatives makes it negative. How about after negative 3, like a negative 5? Still have a negative here, still have a negative here, have a negative here, I have a negative here. Every pair of negatives will be positive, and that's what we have. It's a positive. What's my answer? Everywhere that it's negative. So between a negative 3 and a negative 1, and from 4 to infinity. And we're going to put those sets together. Why is it negative? Because the product needs to be less than 0, and less than 0 is negative. Whew. All right, we got to do a rational function. All right, so here's the rule for rational functions. Solve it as if it's an equal sign. But when I say solve it, I mean place the values that make both the top and the bottom equal to 0 on a number line. Because remember, when you multiplied, what we cared about is where they switched signs, where they were 0. Well, they're going to switch signs when the top or the bottom switches from positive to negative. Right? Because a positive divided by a positive will be positive, or a negative divided by a negative will be positive. So I care about the sign of both the top and the bottom. So I need to find out where will the top and the bottom be 0, and put those on a number line. So I have negative 3 and negative 1, right? X equals negative 1 makes the top 0. X equals negative 3 makes the bottom 0. And now it's the exact same process. What number out here? So like something bigger than negative 1, like 0. Whoops. 0 plus 1 is positive. 0 plus 3 is positive. Out there is positive. Something between a negative 3 and negative 1, like a negative 2, makes that negative. That's still positive. That's negative. And as you would guess, that goes to positive. Okay. Slight difference. I'm going to change this. It'll be an easy fix for you also. I'm going to make that an equal to. This says that I want values that are greater than or equal to 0. So now I have to concern myself with open circle, closed circle, or parentheses versus bracket. Negative 1. Do I include the negative 1? Will a negative 1 make that fraction 0? Well, it makes the top 0. So is 0 divided by, what would that be, 2? Is 0 divided by 2 0? Yes. So include the negative 1. So I do want to include negative 1 to infinity. How about the negative 3? Do I include the negative 3? If I plug a negative 3 and I get negative 2 on top and I get 0 on the bottom, is a negative 2 divided by 0 0? No. Type it into your calculator. What's your calculator say? Error. Not possible. Can't divide by 0. You can never, as in never, include the value for x that makes the denominator 0. If this is an equal sign, we can include the value that makes the top 0. You can never include the value that makes the bottom 0. If that doesn't have an equal sign, you don't have to worry about it. You're not going to include either one. All right, we're going to do one of those. I know the recording's getting long, but we got to try one that's semi-difficult. Sorry, I don't want to go 5. We'll go 0. All right, hit pause, give it a try. Okay, on my number line, values that make the top 0, negative 3, negative 1. Value that makes the bottom 0, 4. Plug in something greater than 4, like 6. 6 plus 1 is positive. 6 plus 3 is positive. 6 minus 4 is positive. That thing's positive. We know it's going to switch signs, right? Let's just double check. A couple. Put in something between negative 1 and 4, like 0. That makes the top positive. That's positive. But this guy switches now to a negative. Positive times a positive on top is positive, bottom is still negative, and I get a negative. Don't need the 1 there, it's just negative. All right. Can never include the value that makes the bottom 0, so I'm not going to include the 4. I can include the negative 1, so I have a negative 1 to 4, open parenthesis. Why am I doing the negatives? What does that says to? That says values where the product is negative, less than 0, or 0. Don't include the 4. The 4 makes the bottom 0. You can't divide by 0. Do include the negative 1, because negative 1 makes the top 0, and that is 0. All right, over here, negative 3 makes the top 0. I can include it all the way to negative infinity. You can never include the infinity. And we're going to put a union in between the two. Inequality notation, x is less than or equal to a negative 3, or x is less than 4 and greater than or equal to a negative 1. Open, whoops, sorry, close circle, fill that in. Going that way, close circle to an open circle, or we have parentheses going to bracket, we have a bracket going to infinity. All those notations you should know. All right, hope that helps.